Hello everyone, welcome back to another episode of Studysmart. In today's video, we are going to be talking about the WRONSKIAN. Right? So the WRONSKIAN is a function that is used to determine the independent and non-independent cases of a function. Right? So we use the WRONSKIAN to determine if a function if a function if a function is linearly dependent and linearly independent. Alright, so that's one of the major use of the WRONSKIAN. Secondly, we use the WRONSKIAN to solve or determine the solution of a non-homogeneous equation. Right? Um, Solution of non-homogeneous equation, homogeneous differential equation, mostly the variation of parameters. And so variation of parameters. The WRONSKIAN of a given function is given by or expressed by the expression right. So let us say this nth solution of a given function, and the WRONSKIAN of these functions is given by the determinant of this function. Right. So this is the determinant of y1 of x, y2 of x, down to yn of x. Right. So to get the other functions in the determinant, we are going to differentiate this as many times as possible. We're going to differentiate this given solution nth times. It means that we're going to differentiate it as many as possible. Right. So since we have three sets of solution here, right. So all right, this is more than three sets of solution because I said this continuous till the end solution. All right. So if I take the differential of this, I'm going to have y prime of 1 of x, I have y prime 2 of x, and I also have y prime n of x. Alright, so this continues to the form, it continues till y1 n minus 1 of x and yn minus 1 of 2 of x down to yn minus 1 n of x. Alright, so this the expression of a WRONSKIAN. This is how a WRONSKIAN is being expressed. Right. So just like I said earlier, I said we use the WRONSKIAN to determine if the function is linearly dependent or independent. Right. So the WRONSKIAN is said to be linearly dependent. Let's take the first one. Linearly dependent. Right. So if a WRONSKIAN is said to be linearly dependent, or a function is said to be linearly dependent, if the WRONSKIAN of the solution y1 of x, y2 of x down to yn of x is equal to 0. Alright, is equal to 0. This is when the function is said to be linearly dependent, when the WRONSKIAN of these solutions is equal to 0. Alright, so the second one is when the function is linearly independent. Alright, so this is linearly independent. Right. A function is said to be linearly independent if the WRONSKIAN is not equal to 0. So if this WRONSKIAN of these given solutions is not equal to 0. Alright, so we are going to be taking some few examples in order to illustrate what I'm talking about here. So let's take the first example. Um, let's take well, okay, find the WRONSKIAN. Find the WRONSKIAN. Find the WRONSKIAN of the solution. Um, we have x sin x, x, comma, sin x, and then I sin x, sin x. Right, so we are asked to look for the WRONSKIAN, meaning that we have to determine if these functions are either linearly dependent or linearly independent. So let's start from this. Just like the expression I gave you earlier, I told you that the WRONSKIAN of this given solution is expressed in this form, which means that my y1 from here is the first function, which is x, and my y2 is sin x. So we are going to be following that. I have the given solution y1, y2 down to yn, and I included and I repeated the solution here, and then I went further in differentiating the solution. Alright, so the cheat here is that if I am given two functions in this form, I'm going to form a 2 by 2 determinant. If I'm giving up to three functions, I will form 3 by 3 determinant. But if I'm giving up to 4 functions, I will also form 4 by 4 determinant. So in this place, they gave us y1, which is x, y2, which is sin x. So we are going to form a 2 by 2 determinant. So the WRONSKIAN of y1, y2 is x and sin x. So I'm going to take the determinant of this, and I'll have x sin x. Yeah, sin x. So I'm going to differentiate this. If I differentiate this, I'm going to have 1. If I differentiate this, I'm having cos x. So I've succeeded in forming a 2 by 2 determinant. This is 2 rows and then 2 columns. So we are going to form this. We are going to solve this determinant using the knowledge of our the initial knowledge we have from solving determinants is the same way we are going to use in solving this. So I'm going to multiply this by this and then minus the product of this and this. So I'm going to multiply x times cos x. X times cos x here is going to give me x cos x, then minus 1 times sin x here will give me sin x. Alright, so if you look at this function very well, this is not equal to 0. There is no further way you are going to solve this thing that is going to give you 0. So this is not equal to 0. So we can conclude by saying that the function f of x, this function, the given WRONSKIAN, is dependent. It's linearly independent rather. It's linearly independent because the solution is not equal to 0. So it's linearly independent. So we are going to check for II. So we're going to check for II. So question II, we have our y1. This is a comma. Our y1 here is sin x. And our y2 is also sin x. So we are going to take the WRONSKIAN, which is y1 comma y2, sin x comma sin x. So I'm going to form a determinant of this. If I form a determinant of this, I'm going to have sin x and sin x. So I'm going to differentiate sin x. If I differentiate sin x once, I'm going to have cos x. If I differentiate sin x, I'll have cos x. Alright, so I've succeeded in forming a 2 by 2 determinant. Alright, so 2 rows and 2 columns. This is 1 2 1 2. Alright, so I'm going to solve this. I'm going to multiply this times this to have sin x cos x. This times this minus this times this. This is minus sin x cos x. Alright, so sin x cos x minus sin x cos x is giving me 0, which means that the function or the solution is linearly dependent. Alright, so it's linearly dependent because it is equal to 0. We are going to take further examples in order for us to illustrate the Wronskian. Let's take a 3 by 3 sample problem. Alright, so we can just say find the Wronskian of the function. Find the Wronskian of the function y1 equal to exponential x, y2 equal to exponential minus x, and y3 equal to exponential minus 2x. Alright, so if you check very well, we have 3 functions here, 1, 2, and 3. So we are going to form a 3 by 3 determinant. So this will be the Wronskian of exponential x, exponential minus x, and exponential minus 2x. Alright, so this is going to give us equal to form a determinant. The first one is exponential x, second one is exponential minus x, the third one is exponential minus 2x. Alright, so if I differentiate this thing, I'm going to differentiate them 3 times. I've differentiate each of the function 3 times because we are having 3 solutions here, 3 functions, 1, 2, and 3. So I'll differentiate them 3 times. So this will give me exponential x. This will give me minus exponential x. If I differentiate it, the minus sign will multiply the function. Alright, so this will give me minus 2 exponential minus 2x. So I'm going to differentiate this again to get exponential x. The minus sign multiplying this changes to plus. It becomes exponential minus x, while this becomes 4 exponential minus 2x. So alright, so I'm going to use basic knowledge of solving a determinant to do this. So the first one I have there is my exponential x into, so the major idea is the sign will move in the form of plus minus plus. Alright, so plus minus plus. If the first number is plus, the next one should be minus, then the other one should be plus, just like that. So this is plus minus plus. So this will be plus this times, if I erase this and I erase this, so I'm going to erase this and then the whole of this. So I can be able to get a 2 by 2 matrix here, a determinant rather. So this is going to give me this times this minus this times this. Alright, so this times this is going to give me minus exponential minus x times, this will be 4 exponential minus 2x. So I have minus this times this exponential minus 2x times minus 2 exponential minus 2x. So this is what I have. So that's for this. So when I move over to this, the sign will change to a minus. This will be minus exponential minus x times. So the whole of this part will go and the whole of this. So I'm going to have this and this. So this times this is going to give me exponential x times 4 exponential minus 2x with 4 exponential minus 2x, then minus this times this. So this will be exponential x times minus 2 exponential minus 2x times minus 2 exponential minus 2x. Then the next one there becomes a plus. So this a plus exponential minus 2x. So this is exponential minus 2x multiplied by this part will go and this part. So I'm left with this and this. So this is this times this minus this times this. So exponential x times so exponential x times exponential minus x times exponential minus x minus exponential x times minus exponential minus x, exponential x times minus exponential minus x. Alright, so this is what I have. So I'm going to multiply through. Alright, so the first one I have exponential x into, so this times this is going to give me minus 4 from law of indices. These bases are the same, so I'm going to pick one of it, exponential x, then I will sum up the powers. I'm going to sum up the powers. This is x. This is x. Alright, so because this times this. Alright, so I'm going to sum up the powers. This will be minus x plus minus 2x. So minus x will give me minus 3x. So that's for this. Minus this times this. I'll have minus 2. I have the bases to be the same. I'll pick one of the base and I'm going to add up the power. So minus 2x plus minus 2x. Alright. This is x also. Sorry. And so this times this minus this times this. So x is minus x. So this times this will be minus exponential. Is minus 2 exponential minus x plus minus 2x is going to give me minus 3x. So that's for the first one. I'm going to go over to this one. I have minus exponential minus x into this times this is going to give me 4 exponential. This is x and this is minus 2x. So 1 minus 2x is going to give me minus x. This will give me minus x. Then minus, I have exponential x times minus exponential minus 2x give me minus 2 exponential x minus 2x will give me minus x. Right, so this is what I have. That's for this. So we'll go over to this one. I have plus exponential minus 2x multiplied by exponential x times exponential minus x will give me exponential x minus x here is going to give me a 0. Right, so I have minus exponential x times minus exponential x will give me minus exponential to power 0. Right, so this is what I have. Right, so in solving further the problem, I have this. I'm going to multiply this times this now. I'll multiply this times this. So I have exponential x times minus 4 exponential minus x. I'm going to have minus 4 I'm going to have minus 4, the same thing, we'll do the same thing, exponential, this is x and this is minus 3x. So x minus 3x will give us minus 2x. So that's for this. So minus minus here will give me a plus. I have my 2 and I have exponential minus 3x. So I have a minus exponential x. This is minus. So this becomes this times this. This times this becomes a minus 4 exponential minus 4 exponential. This is minus x and this is minus x. So it's going to be minus 2x. This is minus 2x. So I have this times this now will change to a plus. So here will automatically become a plus. Automatically become a plus. So minus exponential minus x times 2 exponential minus x is going to give us minus exponential minus x. Alright, so this times this, I have minus 2 exponential minus. Alright, so this becomes minus x is going to give me minus 2x. So minus 2x. Alright, so for this, I'm going to have plus. Alright, so this is 1 and this is 1 because anything raised to power 0 is 1. Minus times minus will give me a plus. So I have 1 plus 1 here, which is 2. So 2 times exponential minus 2x will give me 2 exponential minus 2x. Alright, so we can further go with this because this is 2 exponential minus 2x and this is minus 2 exponential minus 2x. So 2 exponential minus 2x can cancel out this. Alright, can cancel out this. So I'm going to be left with 2 exponential minus 3x. Then 4 minus 4 is going to give me minus 8. So I have exponential minus 2x and exponential minus 2x. So this will give me exponential minus 2x. So if you check very well, this is not equal to 0. So this is not equal to 0. So we can say that the function or the solution is linearly independent. Linearly independent. Right, and that becomes the answer to the problem. Right, so this is the end of the video. Don't forget to like, share, and subscribe to the YouTube channel in order for you to get more videos that are loading.